she compromised the German passport system. And the way that she did that is she took the photo of a celebrity online, yeah, took a photo. She then matched that photo, mixed that photo with her own. It's called morphing. She morphed the photo out of two of them, yeah, and actually received a German passport. Yeah. Now with that passport, that's terrible then, because now the big problem with this is because it's morphed, two people could use the same identity. Now I'm not sure I can tell you because I don't know how official it is, but actually there have been problems with, I think they've been reported, but problems with multiple people being able to access the same Aadhaar card. Yeah. Thank you. That has now been stopped, but it's to do with what we call deduplication, where we try to work out, is this person unique? So that's really important about an identity and a biometric. What you have to do is make sure that the biometric you collect is unique. So if we collect a biometric from Somanath, yeah, what we need to make sure is, well, first of all, that it's collectible. We can record it somehow and say, right, this is what Somanath looks like. And when I say it looks like, it could be his DNA, it could be his iris, it could be his face, yeah. And then what happens is somebody will present a presentation, right? It's a presentation will come, and you match it to the reference to Somanath, yeah? Now, what you have to make sure is this should be unique. This thing that we captured, this reference to Somanath should be unique, so that when Somanath presents again, it should be the same, right? It should say that is Somanath, so it should be consistent. But it should be different enough. It doesn't have to be actually unique, but it has to be, because provably unique is hard, right? And if you're only capturing things with a certain size of template, then you know it cannot be unique, because if you have more people than there are the size of the presentation space, the template space, you have to have two duplicates. It's called the pigeonhole principle. Yeah? The pigeonhole principle is essentially this. I've got a set of pigeonholes, and there's n of them. Yeah? I can put up to n things into a box which is unique. Yeah? But if I've got n plus 1 things to put in, somewhere has to have 2. Yeah? So if you're presenting, so you can say, well, it's never going to happen. We're not going to have that infinite, this billions and billions and billions and billions of people. Yeah? But you're still only probabilistically. Anyway, yeah, so this German activist got her passport presented. So what are biometrics? So the basis of digital identity typically these days is biometrics. And you can have physical biometrics, so they're fingerprint, hands, iris patterns, or you can have behavioral, which is handwriting, signature, speech, or gait. Some people would argue that speech is actually a mix of both, because you've got vocal cords, right? So there's only certain things you can do, in a sense, but essentially we keep it to 2. So what happens when we want to create these biometrics? Well, what we have first is a biometric service. So we do some enrollment, yeah? In fact, for Aadhaar, yeah, you have a stage before enrollment, I think. You do registration first, right? First thing is registration. I've left off registration. So registration, where you do something very basic online before you go in to an office to do the enrollment and the capture, right? So I'm going to start now, but you get biometric sensors. And what do you use? You use face, hands, iris as well?
Yes.
All 3. Not all 3 are used when you do it, some are just kept there, right? They're stored. Not very data minimal, right? Anyway, but you have biometric sensors. You capture the modalities, and then what you need to do is pre-process, first of all. Yeah? So you need to make sure the image is clean and consistent. Yeah? Now, here's something that varies. Extracting features. I'm not sure if I had something on that slide. Let's see. Yeah, okay. You can see a little here, right? There's two ways to essentially capture features. One is very much with a geometric point of view. And it's interesting that fingerprints, we still use some sort of image processing on it. So what we do is we find different parts of the fingerprint. So there's different things called like a tented arch or a delta point, a whirl. Yeah, we find these points, and what we do is we measure between them the angle and distances, and that's consistent because, you know, when we're an adult, it doesn't change very much. Problem when you're a child, because there's a lot of water in your skin, you can't get a good acquisition, you're growing and you have to stretch and things like that. But face, what we used to do is we'd identify points. If you remember with face, it says keep consistent. There's two reasons for that. But one is you'd measure certain points on the mouth and certain points on the eyes and the cheeks, and then you do the measurements the same. Obviously, that's not very good measurement. So now we use much more around facial, you know, deep learning kind of machine learning approaches, yeah, to do recognition, because it gives you higher order rather than this set of distances and angles. Now you can get a much more nuanced, and you get relationships that you couldn't see before. So that's where you're extracting the features, okay? You then, from those features, yeah, you have a template. So as I said, for machine learning, the template doesn't necessarily mean the distance between your eyes, and it could be a bit different for different people, what it means. They'll still have some same similarities that it's around the eyes, because that's the important thing that defines you, right? So it's about what defines you, but it won't be quite as consistent as for a fingerprint, where the template literally is distance between and angle between. And from that, you get an encoded value. And that is what I call the reference. Yeah? That encoded value is the reference that defines who somebody is. And you may actually have that encoded value as a small set of things, right? So, what do we do then? Well, what we do is we take our biometric modalities and they go into a biometric sensor, okay? So that could be a camera system for your face, it could be a camera system for your gait. So now, more countries are looking at the way you walk to see if they can at least not necessarily identify you, but get an idea out of a set who you are for when you go to through passport control. Yeah. So what they're trying to do is be completely contactless. Don't stop you. Keep walking, and we will identify who you are. There's a big problem with that, which I'll tell you in a minute. But so we can have biometric sensors. Could be cameras. Could be iris scanners, etc. And we have this private database. Yeah. That is the centralized database you might have. Yeah, so the Aadhaar centralized database. And then you have some secure enrollment. Now this, we're starting to look at homomorphic encryption, which is what Somanath's going to talk about. But typically this is a trusted execution, you know, a secure enclave kind of thing, where we know what's going on. And you say either there's an identity match or no match, okay? But there are two types, yeah? And this is what's important. The first is identification, right? I want you to remember that is one-to-N, yeah? One person against a large database. So it's identifying who are you in all of my 1.4 billion people in the Aadhaar database, right? One-to-N is identification, yeah? And it's used to determine who is this person. So this has been trialed in the UK. but the N in the UK was small. It wasn't all people in the national database because we don't have one, but what they said is, we've got some people that we want to find, the bad people. So N was like maybe 1,000 people, yeah, on a wanted list. And they said, right, we're going to do a one-to-N match, yeah. Actually, airports will do that as well, right? So where you've got an N. But what we don't want is that happening regularly, and we don't want that N to be against the national database of citizens, right, or residents, yeah, because that's not what the system was intended for. Scope creep, as I said. So, yeah, so here you go. Law enforcement scanning against criminal database, that happened in the UK. Surveillance that you might do, and border control. Your surveillance could actually be, you might have a set of people in your building and you want to do a one-to-N, because you're trying to say, is it a person that is authorised to be in the building? And if you get no match, you might chase them there. And verification, this is what ADHAR does, is a one-to-one, yeah? So the problem is, look at that identification, one-to-N, yeah, that's what's happening in the Middle East, yeah? So while it's good and you can walk through, somebody's matching who you are without you being active. It's called passive, right? That's a bit worrying for us in some sense, right? Because somebody knows who you are. This is what, you know, that there's companies in the US, Clearview and Palantir, very controversial, that do this kind of thing. Verification is much better, and this is what happens when you use your ADHAR card. Yeah, you tell them, you know, either with your card or with a QR code or something, but you're basically saying, this is me. Yeah. So what it does, it sends off only some very basic information. It sends off some biometric information to the ADHAR database. And what happens then is, think that there's a whole lot of lockers of people's biometrics, yeah? All that the system can do is go to one locker and say, open it up and say, right, I'm going to compare the biometric in there to the one you've just given me, and it will say, yeah, you're all good, or it'll say no. Doesn't say what you can do after that. It just sends a signal back saying yes or no, yeah? And that's good. So long as you can't have a backdoor in ADHAR where somebody can say, oh, check that door, no, check the next one, because then you're doing one-to-one, N times, big N times, is one-to-N matching, right? So, let's have a look. So there are various threats. So what we've done is, we've got this paper that's just out now that looks at the 3 key areas of biometric systems. They are unauthorized access, so the security, spoofing, data breaches, yeah? So these are where you're trying to compromise. So this is an impersonation attack. You would have on here probably the evasion attack that you mentioned before, yeah? Privacy concerns are identity tracking, mass surveillance, and data misuse. And in fairness, you could have algorithmic bias and exclusion of certain demographics. I'll turn that off. I'll do that. Right, okay. So this, wrong button. So this, and it's not so clear at the back, I know. Let's see. Okay, you're going to get, I'll send you, I think we're going to give them copies of the slides anyway, right? Yeah. So you'll have them before Friday. But NIST and ISO have prepared a number of different, so ISO is an organization, the International Standards Organization. It has created a set of standards around biometric systems. This one is what's called the reference architecture. So a reference architecture, yeah? Put your hands up if you've heard of a reference architecture before. Okay, a reference architecture for anyone designing a system is really useful and important. So I've written reference architectures for space systems, for vehicular systems, and the reason I do this this reference architecture is because it helps us spot, instead of going local, it helps us give a big picture and spot new threats. Yeah, and in one paper that I created, there was an attack on a Jeep, yeah, where people had full access control. That actually would have been prevented if the security analysts had looked at a reference architecture. It doesn't have to be mine, because it can be slightly different. But this is the reference architecture for biometric system. So it helps us see, yeah, this, it wasn't the purpose of this one, this is just to tell people what it looks like, but it helps us see where we can attack things, okay? So it gives us an idea of what's called the threat surface, okay? So what you've got here is, so let's start around here. So here you've got the presentation, yeah, where somebody presents. You've got a captured sample. It will go to create the reference, yeah. So you start with data capture. You go through. You've got reference creation here. You've got the reference that goes into the database, yeah, and you've got a decision system over here. So what you've got, this comparison system, by the way, is called an ABS, yeah, ABIS, yeah, automated biometric identity system. But these are the key elements that you've got. So first of all, is collect those data. Do that signal processing that I mentioned before. Data storage, so you need to store these biometric templates, yeah? And you do that typically, this is a centralized system, so you do that centrally. You have a matching system and a decision system. So, if we consider that, you can see how this maps onto that, right? So you've got the data capture, which was here. You've got the signal processing, which is in the middle there. The decision is there, comparison and storage. So so what this is abstracted those elements, yeah? This is from another ISO standard, yeah? And what it is to work out the attack point. So first of all, yeah, you've got data capture, right? So you can attack at the data capture. So that data capture could be at the enrollment phase, right? And this is what's happened before, where we've had two people with the same Aadhaar number, able to access the same Aadhaar number, because this data capture was compromised, right? So it was what we call a presentation attack, yeah? The way that we stop this most of the time is, as you know, if you register for Aadhaar, there's somebody there, right, doing it. So the first thing is that for this, at the enrollment time, there's an insider that's been involved. That doesn't happen sometimes if you've managed if you have something that's an online or remote enrollment, yeah. But if there's remote enrollment, you've got to be careful for other reasons, yeah. Okay, so you've got data capture where you can do a presentation attack, and that presentation attack might be, so I'm going to tell you one, right? If you're required to put 10 fingers down, yeah, and what you do is then, if you use all those 10 fingers, say, right, there's 10 fingers there, so that's person one, and person two has got 10 fingers. And what you try to do is you say, right, I'll make sure, first of all, you have this deduplication at some point, right? Which makes sure that you don't have two people with the same ID. Yeah? Because people might forget and roll twice. But if somebody puts one hand on the system, and then somebody else puts their hand on, so someone else puts his right hand on. Now we need the collusion here of the person who's doing it. What's going to happen is I'm not going to match this new identity, let's call it this composite identity with me and Somanath. It's not going to match the identity of Carsten, right? Because it hasn't got the same right hand. It's different. it's not going to match the identity of Somanath. It's got a different left hand. So therefore, it will go through the system as a new person. Okay? So that is where one really simple what's called a presentation attack. Others include wearing prosthetics. Yeah. There's some Tom Cruise films called Mission Impossible. He does all sorts of things like this. You know, different. You know, in fact, if you want to see, there is a great example of a good presentation attack. The Samsung, I don't remember which Samsung, it was about 5 years ago, but Samsung brought out iris scanning on the phone for authentication. Apple were about to do the same and stop because of somebody called the German Computer Chaos Club, within 7 days of it being released, managed to compromise the system. Yeah. And the way that they did it was really easy, because all they did is took a high-definition picture of an eyeball, printed it on paper, put that paper into some contact lens that was curved, and then held that up to the iris scanning thing and got into the phone. Yeah. So that was a presentation attack, not at enrollment, but at verification. Okay. So but here the same thing happens. It's a data acquisition. You can modify. So this is not called a presentation attack. Rather, this is when you modify it. It's called an injection attack. You can override a signal processor. Yeah. So that what you're doing is when you get the biometric in, if you override it, you'll corrupt it so the template looks like what you wanted it to look like. And there was a very good attack written around this by Adi Shamir. It's called a backdoor into the AI. Yeah. But when if you did something here, you could get different decisions out. So there's a paper he wrote in about 2022 or 23. So I'd recommend you have a look at that. We found two ways. One is there was a way to manipulate the weights in the machine learning that you were not identifiable as anyone. It's just random. It'd say, you know, I'd be walking along with my vest, and sometimes it would say I was Somanath, other times it'd say it was you, because it couldn't really distinguish properly. And there's another one which what you could do. So that was like the James Bond attack, I think he called it, because I could pass as anyone. But the other one is the one where I can have a template and it's really hard to tell, but I can make sure my template collapses onto somebody else's. I choose them. So that's in the signal processing. You can modify the biometric feature set when it comes out rather than in the processing set. Do it afterwards. Override the comparison tool. So just say, yes, it was a match when it says no. Yeah. You can modify that data storage database. Yeah. Or when it's leaving there, you can see here that all these points are something that's what we call at rest or in motion. Yeah. So it's all of the data as it flows, you can move it at rest or in motion. So in a paper that we released at the end of last year, which I'll encourage you to look at, yeah, there was all these kind of major security incidents. One thing that's important is that these are reported because there was a report that ADHAR unauthorized access and data leak happened in 2018. Enrollment of fictitious entities. That I think probably did happen. Yeah. There was a long time ago, back in 2002, something called gummy fingerprints. Really easy. I did this with my students back in 2002. Yeah. What you do is you get a bottle, yeah, glass bottle. Put a fingerprint on it, so people would leave a fingerprint. You see this in crime movies all the time, right? Then you literally, just like in the crime movie, you dust it. And this is a real thing that we've done with students, right? You dust it, and then you've got a copy of it. You take a photo now, because now you can make a clear photo, and then you print it in a way, yeah, on maybe some acetate, so that it gives the ridges, right? So you print it with the type of printer which will leave some residue. Nowadays, it'd be really easy. You just do it with 3D printing and stuff, right? But I'm talking about what we did in 2002. Yeah. Then you use some latex on it. Yeah. Cover it. And the next thing is you've got a copy of the fingerprint, a very thin latex copy, and it really did fool a number of fingerprint scanners at the time. Here you've got the OPM, the Office of Personnel Management, where there were 5.6 million fingerprints that were leaked in the US. Yeah, you've got 3D printed fingerprints that I just said. That was presented at DEF CON in 2020. Sorry about that. And you've got some of the latest attacks here. So here you've got Clearview AI. That's that company that I mentioned that collects many, many databases, sells it to the FBI and others. Yeah, so what we have done is looked at a taxonomy of security, privacy, and fairness threats, and created some classification. So the first one is, what you can do is attack these sensors, yeah? So it targets the biometric sensor, such as a physical attack, fake fingerprints, or tampering, damaging the sensor that you've got. The raw biometric data level threat, so unauthorized access to the biometric data at the point of capture. Yeah, that's one thing to think about, right? And I guess, you know, if you're a security analyst, you think about this all the time. So the number of times when I engage with a system, I'm always thinking, how can I break it? How can I make it go wrong? Yeah. And at the same time thinking, how can I make the system go wrong? I also think, how could the system be doing bad things to me? So, for example, look at the trust that you put in when you capture. You know, I came into the country and I had to put my fingerprint to get in, and I trust, you know, the Indian border control. I haven't really got much choice apart from not to come in, right? If I don't trust them enough, I could just not come in. If I want to come in, I've got to trust that sensor, and that sensor could be doing anything with that data, right? And in fact, I don't know if you get this in India, but in the UK, the number of times, you know, when you go to an ATM, there are some very sophisticated little devices, physical devices. And what they do is when you put your card in, it's on top of the legitimate ATM. You put your card in, it scans it, you press your number, it's recording that. It's a man-in-the-middle type attack. You're pushing straight down, so you are doing the authentication onto the thing. Yeah? And then you get a notification about your bank. You get your bank details. Somebody else will then steal it and they find your credit card. That's man in the middle. Yeah? So sensors being corrupted is not new. Other threats are supply chain threats. That's in the manufacture or transportation. So many people just think about supply chain being the manufacture, but there's also the logistics part. So the transportation or installation or software upgrades, right? Including backdoor vulnerabilities. Environmental disruption, which is manipulation of environmental conditions to reduce the accuracy. And biometric template level attacks. Then you've got, as I said before, communication and transmission threats. So these man in the middle. So that's the data in transit, as I mentioned. Compromise the algorithms. Yeah, so you'll see here. So that's here, here, here. Yeah. So you can map all these onto that. Operational threats, these are ones where it's not really, the system administrator has been party to it, either negligently or deliberately. So malicious or negligent operational threat, which, when they're malicious, they'll tend to be malicious leaks through an insider threat. So an insider could deliberately misconfigure a server, okay? Privacy threats that we get, now this thing tends not to happen, this linking threat, it can't happen in the ADHA system because they have something called, well, they distribute because they have an aggregation point, so you can't tell who was making the request, yeah? But there are privacy threats about linking connections. That's typically at the foundation level, the functional level of identity. Identification threats, so using biometric traits to identify rather than verify. Non-repudiation, so one thing is you can have the permanent association of biometric data with user actions, removing their deniability and surveillance, right? So what happens is we say it's definitely you. This has come in Hollywood as well because there is a problem, right? If I store a different biometric under your ADHA, and you say, no, but it's me. They say, but you can never match, right? So you've got challenges there. Monitoring biometric usage patterns to infer user activities. Again, that inference coming up. Data disclosure, unawareness. Yes, this is around consent. It's not informed consent. And non-compliance with regulations. And finally, this will be the last slide because we're coming up to the hour. There are problems in bias in recognition. So at the Turing, we've done some work in this. It's very well known that facial recognition systems often, not always, have been developed in the US. Yeah, and in the US, yeah, the demographic is different to Patna. Okay, we know because from some of the big tech companies like Google, that facial recognition systems suffer because there's some bias. So we've heard that from a number of people. Whistleblowing, yeah. So if you don't have the right number of young people or old people or people of a certain skin tone or male or female, that means your algorithm is it hasn't got as much data to learn on, right? So you can have bias in recognition, yeah. And the problem with that is if you've got a biometric system and it's really easy for some people to do something, but there's one group that can't really do anything, and they have to have a different process that might take more time. It might mean that they can't get any access. That is unfair, and that is a problem. And that's related to unequal error rates, yeah? So are your error rates disproportionately affecting minorities or underrepresented groups? And then what about accessibility, yeah? So in fact, I was with Sanjay Jain, does anyone know that name? He was the chief architect, I think, if you look him up, of ADHA. Yeah, I talked to him because I went to the Philippines and I started the registration process. And if you have a missing thumb, yeah, you have to hold up to your camera and have a photograph taken that there's no thumb, and that gets appended so that someone can check. So you can't just say, I'm not going to register it, right? Because it could otherwise be nefarious. So how do you handle? You have to handle people with missing fingers or facial disfigurements, yeah, so that it's fair. So we've created a taxonomy, and as I say, that's in the paper that you can get online. In fact, I'll probably give you a list of references for some of the work. I think I'll stop there. I'll also give you some supplementary notes that you can have just for your pleasure. I'll see how many to give you. But face recognition is one of the most popular, and that's because we already have it on credentials. Accuracy is quite good. There's standards around, so there is an ISO image standard, but there are still a number of problems. Okay, Yeah. Okay, so I'll probably just put details of the facial recognition in some of these notes. But one thing to note is that, so while facial recognition is socially acceptable, don't mind people don't mind them the camera picture taken and why that's good. While we've got a card that we can use, or a QR code even now, right? So you just have a QR code and it's got something in it. And the sensor is available and of quality. The problems are that you've still got people which will give false matches. So we know that in the UK, HSBC, one of the biggest banks in the world, their verification system, I think it was HSBC, or it might have been someone else, who said, "My password is my voice," or something like that. That's a slogan used. And two twins could get into each other's account. Yeah? And might think, oh, it's okay, they're twins, but you know, the twins might not get on, you know? So you've got to think about false matches. And facial recognition thresholds are often too low, yeah, because they don't want you to be locked out. So you've got to get that match between false acceptance, which is somebody compromising your account, and false rejection, which means you can't access your account. Now, why it's so low, yeah, and a lot of this came from a talk from somebody at NIST, actually. Why it is so low is because what they're thinking is, well, it has to be someone who looks a bit like you anyway, right? So that's why family members and other problems are it's biometrics. Sometimes these for face it is biased. The other thing is the face is not a secret, so you can take a face. But then again, there were some things where people, Barack Obama got his hand on, and someone got a good image of his fingerprint off it. So it can happen with others, but it's very passive. You see. There are challenges around, are the sensors cryptographically authenticated? There are things that we can do to tell certain things about cameras, but that's difficult. And as I said, morphing, because of that German case, was difficult to detect. So, yeah, I'll leave it there. Any questions at all? Yeah? Sorry, how model poisoning? In real life, model poisoning in this kind of system. So model poisoning is a challenge because what you're doing is giving quite a few sets of data. So what you need on a live biometric system, it's very hard to do model poisoning at the presentation stage. Okay, so let me just show you here. If you wanted to poison a model, now you know about Aadhaar, right? You've got to do the registration first, and unless you've got a registration token, you can't do the enrollment, right? So your problem is around anything like that. If you're going to get it at the enrollment stage, you're going to poison, or indeed, if you think that the matching algorithm, yeah, is going to use some kind of machine learning here, and that if that was changing by putting loads of presentations, it's going to be really hard because you need lots of people to collude with. So what you would be doing really is injecting in transit. That's where your attacks would be. So they would be typically here, modifying the biometric, each set up, put a whole load of new ones in, or modify the samples here as they come in. So you wouldn't modify, you could either modify each sample as it came in, depending how far the chain you go, or where it's aggregated, just say, oh, there's this bunch that have come in. And that's why you need a good intrusion detection system. Okay. Anything else? Okay, well, 15-minute break then, and then Somanath will lead the way with you.
Yeah, he's outside.
Yeah.
Right.
So yesterday, tomorrow, actually, I was really meeting something there. So we'll do the department meeting there. Okay. So for your remembrance, I wrote it. Department meeting with your
Okay, cool. Brilliant. Okay.
So, you will go to guest house, right?
Yeah. It'll be.
He will drop you.
Okay, super.
Yeah, I will give my class.
That's okay.
Right? Okay.
Thank you.
Yeah. I am not going. He will go. Therefore, you can stay here for 10 minutes.
Okay.
Have a cup of coffee, right? You will.
Thank you for that. It's like 40 minutes walk, I think.